All right, welcome everybody. In this video, we are going to all right, welcome everybody. In this video, we are going to work with data frames and we're going to talk about how we can construct a data frame from scratch. And then as we work through this module, and there's a link to this Colab notebook in the description of this video. We'll be working with data frames that we import from an external CSV file. And the focus of this entire module is going to be how can we extract and slice and subset larger data frames. But to get things going in this module, let's first kind of construct a smaller data frame just to refresh ourselves with the data structure of a data frame. Okay, so data frames, when we set them up, if they are what we so-call are it's structured as tidy, then each column of a data frame is going to be a vector, and each of those vectors is going to be a single data type, and so and correspond to a different variable. And so if the column, if the variable is numeric, then that column might be of integer data type. It might be a double data type if it's a decimal. If the column variable is categorical, then we might store it as a character or a factor. We might have it as a logical and so on. So if we were to say construct a data frame from scratch, then one way that we can create the data frame would be to first load each column as a separate vector. And so that's what this code cell is doing down here. I've got one vector that I'm calling D, and this is a vector that contains four different integers. So the first entry, the first element of my vector is the integer 2, then 4, then 6, and then 8. And so the way that we code integers in R is we enter it with an L afterwards. So the 2L here is indicating the integer 2. 4L is the integer 4, and so on. So this vector D is now a vector. The data type is integer, and it's got four values, 2, 4, 6, and 8. The next vector that's going to be the second column of my data frame is E, and this is a vector of decimals. So this is going to be a data type double. And by default, if I just type a number 2, this is going to store it as a decimal. So if I want it to be an integer, just keep in mind in general, then I need to enter the L afterwards. So vector E is a vector of decimals that I've entered below. Vector F that I've entered below here. This is a vector of characters, red, white, and blue, and it's got one missing value. And I want that missing value to be coded correctly as an NA. And notice I have not put that in quotes. If I put that in quotes, then that would be treated as the character string of the letter N followed by the letter A, which is not missing. That's actually the character NA. So I want this to be a missing value. That's just NA, not in quotes. But this entire vector is going to be treated as a vector of characters. It's got three values and then one missing value. And then vector G is a vector of logicals, true, 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 and false. And again, these are not written in quotes. So if I were to put these in quotes, then these would suddenly be character strings of the letters T, R, U, and E, which are treated differently internally in R than the logical true. So if I want to create a data frame, one way to do it from scratch, one way to do it is to first define each column vector. So I've got four different column vectors that I've stored into vectors that I've named D, E, F, and G. And then we've got a new function here that's called the data frame function. So it's data.frame. And then I just enter each of the names of the column of the vectors that I want to enter for the columns. And then we can check the result in the end. So here I'm storing the resulting data frame to an object that I'm calling df to stand for data frame. So let me run this code cell. I'm going to get a warning since this is the first time I'm running this. Okay, sorry, I've got too many sessions that are running. That's good to know that if you're don't have a professional Colab account, then you are limited to how many Colab sessions you can run at once. I exceeded that, so I closed all of my other Colab sessions. If you ever get that warning, that's what that means. Now I'm just running one Colab session, this one right now. And so I ran this code cell, and here's the data frame that I just created. This has 4 columns, D, E, F, and G, and we can see the data type of each of them. The first one was a vector of integers. That was column D. The second column, E, was decimals. The third column was a vector of characters, and then the last column was a column of logicals. And we can see this printed to the screen. Great. What we often have with data frames is we would like to name the columns like something descriptive of the variable that is being stored in that column. In this case, our variables, we just made these up, so we're not actually working with like actual data that comes from a context just yet. But let's say, for example, column D, this first variable was an identifier, an ID. Column E corresponded to some measurement that we had. Column F is the color. Column G is whether or not that observation passed some test, true or false. So we want to name column D, we want to give it a name of ID. Column E, we want to give it a name of measure. Column F, we want to call that variable color. And column G, we want to call that variable passed. Then I can name each of these columns by using the names function. And what I want to do is I'm going to apply this function to the data frame that we stored above that we call df. So I'm going to give names to the columns of the data frame that we call df. And I'm going to give those names, I'm going to pass them inside of a vector. That's what this C is denoting here. So we're going to create a vector, and we're going to give it inside of the vector, we're going to give it 4 different names inside of quotes. So we'll run this, and then we'll print the corresponding output. And now this just replaced the original names of D, E, F, and G with more descriptive names of ID, measure, color, and passed, for example. And we could have combined these 2 steps, creating the data frame and giving the columns more descriptive names in one shot by doing something such as this last code cell that we'll cover in this video at least. So inside of the data frame function, up here we just said D, E, F, and G, but I can actually pass names inside of this function by saying we're going to first input D, but we're going to call it ID. So we're going to say my column names are going to be ID, measure, color, and passed. And that first name, its data is going to come from vector D. That second variable that we're calling measure, its data is going to come from the data that we stored in vector E, and so on. And so one important thing to note here is that when we used the names function to give names to the columns, we put them inside of quotes. When I named my columns inside of the data frame function, we don't put them inside of quotes. And so let me run this. Notice here I'm creating a new data frame called df2 as opposed to the one that we created above. And this is just the same exact data frame that we already created. Here we just created it a little bit differently. So the first method was first we created a data frame from the vectors that had like non-descriptive names, and then we gave them names with the names function. And now those names we had to put inside of quotes. Another method to do the same exact thing is to just use the data frame function, but give the names inside of the data frame function using this syntax below. And in this case, we don't put the names inside of quotes. Okay, so we'll stop at this point for this first video, and we'll continue working through this module in the rest of the videos for this week. Thanks, everyone.